Hi, so for this section, we're going to look into the design of slender steel columns under uh, centric loading. So depending on the material, you always have a graph like this, okay? And for this case, this is for structural steel. If your structure is aluminum, the curve looks the same, but the coefficients are different, okay? So what you see over here, this graph over here, okay, is acquired experimentally. So you have to do quite a bit of experiment. Okay, so organization, we have done this for you. Okay, so if your critical stress, okay, if your L over R and your critical stress is between A to B, so we look at between A to B. Okay, so between A to B, right? You will calculate your critical stress based on this formula over here. Okay, so critical stress equal to 0.658 power by stress Y over stress E, close bracket, and this is your stress U. So this equation over here, now this is between point A to point B. Okay, point A, point B. It's only valid when the L over R is less than 4.71, okay, square root of E divided by stress Y. Okay, so this is where these terms come in over here. Okay, where stress Y is your U strength, and then your stress E will be equal to stress E is equal to standard formula, right, over L over R squared. Okay, and when it's between, so this is between A to B. Okay, then if it's between B to C, right, so i.e. B to C means this range of slenderness ratio, or anything that is greater than 4.71, okay, and this height of your U stress. So you have a critical load, so then you apply this set of formula where your critical load will be equal to 0.877 stress E, right, and this is only valid when, like what I mentioned earlier, your L over R ratio is greater than 4.71 square root of E divided by stress Y. And then at point B, exactly at point B, okay, so exactly at point B over here, okay, exactly at point B, right, exactly at point B, down here now, then your L over R, right, your L over R will be equal to 4.71 square root of E over by stress Y, right? So when this stage, your stress allowable will be equal to stress critical divided by 1.67, and this is for structure steel. Okay, for structure. Okay, this is special for structure steel. So the procedure for solving, right? So the procedure for solving buckling is always to find the L over R ratio. Okay, always. Okay, so that is all I'm going to do for this series. The next time when I come back, we're going to look at an example to how to design the structure seal column under centric loading. Thank you.